So our last speaker is Claire Yang, also from the University of Minnesota. And Claire is actually an undergraduate, and so that is fantastic to have you here. Thanks for being with us.
Thank you.
And Claire is going to be talking to us today about representing altruism in multi-agent theory of minds, and I am expecting to be blown away here. So please take it away.
Well, I hope so. Here, let me share my screen.
Looks good. Okay, yeah. Whenever you are ready, stage is yours.
Yeah. So this is my first time publicly presenting any research work, so I'm very excited and thankful to Neuromatch for this opportunity. So today I'm going to be talking about representing altruism in multi-agent theory of minds. As you can see, I guess from Zoom, my name is Claire Yang, and I'm a senior undergraduate at the University of Minnesota. And I'm collaborating with Joseph Blanchard, who is a master's student, he's on the call, at the University of Minnesota, and also Dr. Paul Schrader. So there we go. Quick definition to start off with. Theory of minds is the ability to perceive and understand the motivations, goals, and beliefs of oneself and of other people. So this ability is really important for cooperative behavior between multiple agents because, one, it allows agents to anticipate other agents' needs based off of their inferred goals and thus work together. So previous work in multi-agent theory of minds has focused on modeling agents who are assumed to have selfish motivations. However, cooperative behavior is difficult to understand if everyone is acting selfishly. And now more than ever in the world, it's very important to understand and study like unselfish behavior and cooperation. So first, in order to solve this problem, we need a way for agents to be able to think about what others are thinking about to a certain kind of like recursive depth. So following the two works cited at the bottom of the slide, we model the agents in what is called a cognitive hierarchy. So basically, a cognitive hierarchy defines agents at different levels, where agents at different levels will follow different policies and take kind of the lower level agents' actions into account in their policies. So for example, a level 0 agent's policy can be to randomly select their actions, right? They just maximize their actions or randomly select them with no regard for any other agent's potential actions. A level 1 agent will anticipate the other agents to be level 0 and choose their actions accordingly. And a level 2 agent will, again, do the same, assume other agents to be level 1 or level 0 and also choose their actions accordingly. So our work extends the idea of composable team hierarchies from Chamet et al.'s paper, Theory of Minds, Understanding Behavior in Groups Through Inverse Planning. So basically, a composable team hierarchy formalizes the idea of a cognitive hierarchy as described in the previous slide, but uses it in multi-agent planning. So basically what that means is in a composable team hierarchy, basically each level agent is assumed to have certain reward structures for different combinations of level 0, level 1, or level 2 agents. And based on these assumptions of the reward structures, you can infer over the hidden relationships. The assumptions, however, that Chamet et al. Made was first that each agent is selfishly motivated, and second, that each agent thinks that the other players are less strategic than themselves. So we hope to kind of break out that first assumption and allow for unselfishly motivated behavior. So our work investigates non-selfishly motivated behavior through a different reward structure in the composable team hierarchy, and also it goes a little bit beyond Chamet et al. And introduces the notion of like a social grouping or a team by combining multiple composable team hierarchies so that we can hopefully study team dynamics. So we implemented our model and ran it in a stag hunt simulation. And if you don't know what a stag hunt scenario is, it's basically a classic game theory problem that has been used to study multi-agent behavior. In this scenario, there are 3 agents. Each of them are hunters who are trying to either catch the stag or the hare. The stag, if it's caught, has a very large reward, whereas the hare has a much smaller reward, and the game will terminate when either of them are caught. As you can see, so on the left, there's a screenshot of what the simulation looks like. The stag will move around to avoid being caught, and so thus it can only be caught if 2 agents cooperate on catching it. And so say if 2 agents do catch it, they'll split the reward and each, in this case, take home 10 points each. And the second addition to the stag hunt scenario that we added in was an action of altruistic declarations. So, right, there's the action space consists of being able to move up, down, left, and right, and also declare your altruism at any time step to any other agent. So this declaration basically signals a willingness to cooperate. And as you can see on the bottom right, so the way that I guess I denoted it is the blue agent is not cooperating or has not declared themselves altruistic to any other agent. And the red one has declared themselves to be altruistic towards purple and blue, and purple to red. So in this example, if blue and red were to catch the stag, and in that time step, purple was still altruistically, I guess, declarative towards red, then purple would also share in the reward of catching the stag because they have declared themselves to be, I don't know, like altruistic and thus supportive, and therefore they also get a reward out of that. So our preliminary results basically show that higher level agents are more likely to declare altruism towards other players, in that an agent's altruistic declarations have a notable effect on the inferred teams and the other players' actions. So I did include these videos. We can go into them later, but basically they just show the 2 different, I guess, like situations, one of which is where all the agents are level 1 agents, so lower level agents, and the second one where all the agents are level 2 agents. So given these preliminary results, we hope to continue first experimenting with the reward structure to see if we can simulate more altruistic behaviors, and also add in a dictator game, which is a different game theory game that allows the agents to actually truly signal whether they're being altruistic, because an altruistic declaration does not actually mean altruistic behavior. And in the future, it would be great to be able to utilize this environment to study kind of perception and perception of cooperation in depressed people versus non-depressed people to understand and kind of introduce a novel methodology into that line of work. So yeah, here's me and my collaborators' contact information if you'd like to follow up, and thank you very much.
Fabulous. Thank you, Claire. And in lieu of applause, please drop your praise in the chat so that people can see how we appreciated Claire's talk. This was really interesting. Thanks. We have a few minutes for questions, actually, which is nice because these are supposed to be the interactive talks. So please utilize that Q&A box or the chat. And to get us going while we're waiting for a few questions to come in, I have a question which may be very obvious and maybe is the question you get all the time. But it struck me that this other assumption that the Shun et al. Paper from 2019 is making, which is that each agent assumes that the other agents are a level below it, or at least 2 levels below it. Right. That strikes me as a very artificial assumption for an agent to make, or maybe I'm just reading, I have too much hope for humanity, I'm not sure. But are there plans, or how do you see that assumption interacts with these declarations of altruism? Would they drastically change if you relaxed that assumption?
That's a good question. I guess I've thought about that a bit, and I don't know that I have a definitive answer, but I think the reason why it's assumed that the other agents are at lower levels than, I guess, the root agent, if that, like I would think that these 2 other players are at a lower, less strategic level than me, are basically to limit the space of possibilities, because it's impossible for you to infer what someone else who is more strategic than you would do, right, in the next time step, or what kind of policy they would follow. But if you assume that you are the most strategic person, then you would basically be able to kind of, I guess, assume their policies and then kind of act accordingly. So I think that's the main limitation of the cognitive hierarchy. And it's something that was studied, I guess, in game theory. And my best guess is that it's so it limits the space of possibilities.
Sure. And this is far from my area of expertise. So I study metacognition and know about theory of mind, but game theory is a little outside what I do.
Oh
So,
yeah, I'm still learning too. So.
but it strikes me that an agent, and Arun, I know you're in the same lab, and so you guys are talking about metacognition and theory of mind, and it struck me that an agent that has kind of metacognitive abstraction capacity might be able to simulate another agent, or at least like predict another agent that is on its level, using those metacognitive faculties. And so, of course, it wouldn't be that an agent could simulate or predict a more advanced agent or a more strategic agent. But what about those on the same level? Is that just not possible?
That might be a question for Arun, if you'd like to take that.
So it should be able to really, this metacognition process, the way we see it, should be able to generate the pathways in some way. So like it's like traversal between high level to lower level, if you see. So by generating those pathways, it should be able to really influence the lower level pathway. That's what I could really think about if I understood your question appropriately. So there's interaction between these hierarchies, but like the generative process at the top of the hierarchy should really somehow influence this lower level hierarchy part. So it might be the similar part in this multi-agent scenario as well. I'm not sure, but.
Got it.
Cool. Yeah. Please jump in, and other folks too. Like, we've got a couple minutes here. These are meant to be interactive talks. So if you want to jump in and join the fray, we've got some questions coming in as well. And Claire, did you want to follow up on that?
Oh yeah, no, I mean, I think that's a great insight and something I didn't really think about before.
Great. And we can talk about this more later, but in the meantime, we've got a couple of questions who have come in. That look like they're for you, Claire. So the first question that came in is from Ben Zarov. And Ben is asking, is it possible to formalize what percentage of action a more strategic agent would not do, assuming there are actions that are explicitly bad?
Okay, let me think about that. So is it possible to have actions, like have a probability? I guess, yeah, I'm having a little bit of trouble understanding that.
Sure. Ben, I handed you a microphone. Do you want to clarify a little bit? Oh, you don't have a microphone here. Oh, darn. Okay.
Oh, no. Okay.
Well, maybe we can think, you want to try via text? Okay. Think about it, clarify. And in the meantime, we'll go to Patrick's question and we'll come back.
Cool.
Okay. So Patrick is asking, in the stag hunt scenario, wouldn't the agent always be incentivized to declare altruism? This is a great question.
Right. So that's something that we were kind of struggling with, where we were like, okay, is this really altruism if they are doing it because they want to share in the reward? And that actually is something that varied with the level of the agents that were in the simulation. And so that's, I guess, that's why I included the videos. So for example, the level 1 agents, they all assume the other agents to be level 0 agents who are taking no one else into consideration. And so these games end really fast. I don't know how clear this is, but you can see that they just kind of go after the stag and they just go for it. And they don't necessarily take time to change their altruism. And unfortunately, I don't really have a graphic representation of this because it was just printed in the terminal, but like the level 2 game right here, let me speed it up. Oh no. But basically, this is all level 2 agents, and they're very relaxed. They just keep on changing their altruism and kind of dilly-dallying because they expect that the other agents are probably level 1 agents. And as a result, level 1 agents will probably think that the other agents are level 0 agents. And it's kind of like, oh, I think that you might think this, so therefore I'm going to do this, and I'm not going to move towards the stag. And so, yeah, I guess the biggest finding is that the level of the agent really influences the behavior. And I think it is right to kind of continue to investigate whether that's actually altruistic, if we define altruistic behavior as like unselfishly motivated behavior. Did that answer your question, Patrick? Or if you have a follow-up question, that's good too.
I actually do have a follow-up question.
Yeah.
So in the level 1 video that you showed, is the cooperation, like, so you mentioned that catching the stag requires cooperation.
Right.
Is
Yep.
that cooperation just happening essentially randomly because each agent just wants to capture the stag?
Yes, because they're basically very motivated to catch the stag, just because the stag, if they catch it, will give them 10 points, assuming that no one else is sharing their, or only one other person is sharing the reward, and then the hare will give you 5 points. Yeah,
Okay.
so I would say it's just, you know, they're just trying to go for the stag, and I don't think it's necessarily a matter of, oh, I'm trying to cooperate with red or purple if I'm blue. I'm just gonna go for the stag and try and corner it and get the reward as a result.
Thank you. This is very interesting.
Yep.
Okay, so we have a follow-up from Ben very quickly before we have to close out the meeting. So I'm just going to read it for the folks on the live stream and the recording. Ben Zarov is saying, I was thinking about your statement that it would be impossible to intuit what a more strategic agent would do, which led me to wonder if it was possible to intuit a set of actions that a more strategic agent would not do. I may be thinking about this wrong.
I guess I'll have to think about that more. Because I guess there's like the set of all possible actions. So if you don't know what a more strategic agent would do, and you assume that that space, or like the set of all possible actions minus the set of actions that an agent could do, the leftover would be like what they couldn't do, then I don't know. I feel like you would have to know one to know the other, but that's just like initial thoughts on that.
Okay. Well, I think with that, we have to close up the room before we get booted out for the next meeting. But I would like to thank again all of our speakers. This was a really fun and engaging session. So thank you, Isabel. Thank you, Arun and Claire, for being here and being part of this. And if you want to continue the conversation, of course, you can always go through find your Neuromatch matches, or just follow people up through kind of traditional means. So thanks again to all of our speakers, and also to our backend technical host, Siddharth Suresh, for making this run smoothly. And we will see you in the next session. All right. Bye, guys.
Bye. Thank you.
Thank you. Bye.